This is the second lecture for Chapter 4, Atoms and Elements, and it will cover sections 3, 4, and 5. Section 3 is on the atom. The word atom comes from the ancient Greek word for indestructible, which was given to us by the Greek philosopher Democritus. He thought that if you took matter, you could cut it up so many times until there was a point where it couldn't be cut up anymore, and that point was the atom. He noticed you could cut an apple into thin slices, and one slice would be bigger than the other based upon the curvature of the apple. But at some point, it becomes too thin to cut. So at that point, you'd have an atom. And we now call the atom the smallest unit of matter that still retains the property of an element. So there's 118 elements that we know of that have been discovered. Those are the things in the periodic table. It's the simplest form of matter. They cannot be broken down into things that retain their properties. But you can have a group of atoms of an element, like let's say carbon. You can have pure carbon, a diamond ring, for example. Every atom in there is a carbon atom. There's nothing else in a pure diamond, but it's a giant big structure made up of all of these atoms. If you break it into smaller pieces, you're still just going to have carbon atoms. John Dalton is the man credited with giving us the modern atomic theory, and he said that each element is made up of tiny particles called atoms. He got the idea by looking up and studying the philosophies of Democritus. The second principle here is the atoms of a given element are identical. The atoms of different elements are different in some fundamental way or ways. That he didn't have any way to know what caused them to be different. He just knew they were different. Principle 3 says that chemical compounds are formed when atoms of different elements combine with each other, and a given compound always has the same relative numbers and types of atoms. This would be like saying water is always H2O. It's never HO or H3O or H2O2 or H3O5. Water is always H2O. The fourth principle says that chemical reactions involve a reorganization of the elements, changes in the way they are bound together. The atoms themselves are not changed in a chemical reaction. Now, each of these principles has flaws, but Dalton didn't really have any way to know that there were flaws in them because mostly they lie within subatomic particles and how they interact and behave in chemical reactions. But this was much before the discovery of these subatomic particles. So subatomic particles are the particles that make up an atom, essentially. The electron, the proton, and the neutron. Those are the three subatomic particles. Electrons are negatively charged particles that move around outside of the nucleus of the atom. Protons are positively charged particles inside the nucleus of the atom. Neutrons are particles that are inside the nucleus of the atom, just like protons, but they carry no charge. And the nucleus is the center of the atom containing the nucleons, which are protons and neutrons. It is positively charged because it has protons. Neutrons are neutral, so it doesn't affect the charge. And it is extremely dense. In fact, it's about as dense or even denser than our own sun. If you know anything about physics, stars and black holes and such are extremely dense bodies of matter. And finally, it is surrounded by a cloud of electrons as we know it today. This image here shows how the electron was actually discovered. It is called a cathode-ray tube. And it was used by a man named JJ Thomson in the mid-1800s or late 1800s. That's an N, not an M. There we go. And basically what happens is you have this tube right here that had a gas in it that was evacuated with a vacuum pump. Inside of that tube are metal electrodes, and you can see we have the cathode on the left, an anode on the right. The cathode is negatively charged, the anode is positively charged, and that is based upon this battery source right here, high voltage it says. So the battery sends out electricity to the plates, and JJ Thomson noticed that when he turned this on, a beam formed, and it always traveled from the cathode towards the anode. So he called it a cathode ray, since it's emanating from the cathode. Okay, so it traveled in the left to right direction in this picture. He also noticed that if he took either magnets or other positively charged plates and surrounded those, surrounded the tube with those, that the beam of electrons would be deflected either away from one of the plates or towards the other. In the picture here, there's a positively charged plate above and a negatively charged plate below. The beam of electrons was deflected towards the positive plate. And it was also deflected towards the positive pole of a magnet, the north pole of it. And he also noticed it's deflected away from negatively charged plates, like if the positively charged plate wasn't there and there was just this one, it would go away from it. And same thing with the magnets, one or the other would deflect it towards the positive end or away from the negative end. They already knew about how charges worked and opposites attracting at that time, so JJ Thomson reasoned that whatever is in these beams is negatively charged. He also noticed that it didn't matter what the electrodes were made out of. He noticed it didn't matter what gas was inside of the cathode ray tube in here. The gas and the electrodes were insignificant to what was happening as far as were these beams being formed, did they deflect at different rates, I guess, or at different magnitudes. He noticed that they didn't make any difference. So he reasoned that whatever was making up these cathode rays, they were some essential component to all atoms of all elements. And he called them corpuscles, little bodies. He didn't know what they were. Later it was determined that they were, in fact, electrons. JJ Thomson came up with the Plum-Pudding model of the atom based upon this research. And you can see in the picture there that the atom was figured to be a sphere. And in that sphere there were negatively charged electrons, which would be the quote-unquote plums. Now, he was British, and in England, British people call raisins plums, and they call cake pudding for some reason. So a plum pudding model is really a raisin cake model, where the cake part of the cake, the batter, the bread, that is the positively charged material within the atom, and the raisins would be the electrons or the negatively charged parts of the atom.